Back in July of 2008, the Queensland government introduced the solar bonus scheme to incentivise residential customers to install grid-connected solar systems. Now, that was taken up with great gusto, apparently, because by July 2012, they'd canned it. So I think it was overly successful from their perspective, and they could see a looming problem coming with that they'd have all these people who were receiving in total a 52-cent feed-in tariff. So every kilowatt hour you sold to the grid, to the energy supplier, you got 52 cents paid to you. We were buying electricity at the time for around about 25 or 26 cents, I think, per kilowatt hour. So it was quite good. I mean, we're getting twice what you paid for it for feeding it in. Now, there were limitations on that those systems. If you installed it, typically at the time there were 3 kilowatt, 5 kilowatt systems, and you had to pay for it all up front. There were no payment payoff schemes going from the suppliers. Generally finance. I suppose you got to finance, but anyway, we had to pay for that up front. I think it was about $8,500 for a 3 kilowatt system, which is what I installed in 2011. And that's been great. Now, there's a number of factors that have affected this since installation. The performance of the system has degraded to some extent. The solar panels age, regardless of what they say about performance guarantees. You could go down the road of pursuing possibly trying to get that improved, but at the end of the day, generally you're locked into what you've got. My 3 kilowatt system, I increased the solar array on that to 4.5 kilowatts back in about 2015. I bought another 12 panels and put them on. I had an existing 12. I doubled it pretty much, and that improved things a bit because the inverter ran harder when it was in full sun. Now, part of the problem I had too was I had significant shading on the property from 2 large trees. I had one that stopped me getting full sun in the morning until around about 10:30, 11 o'clock. I also had a big tree that started affecting shading on the part of the array from about midday, and so that really precluded its full performance for many years, and until we took those trees out, which we did in conjunction with our neighbours, as they were causing problems. That significantly boosted performance, but that was offset to some degree by the degradation in the panels over those years. So by now I've got as much as I can get out of this system, because I can't change it. I'm locked in with what I've got. I can't put a bigger system in. I'd love to have a 5 kilowatt or something greater. I can't put a bigger system in without losing my feed-in tariff. I cannot change it. I'm stuck with what I've got. I can do a like-for-like replacement. If I wanted to change those panels now, I can't install 4.5 kilowatts of panels. I can only install 3 kilowatts or less. That's the rules now. So I would actually end up with probably less. So really I'm locked in with that. I can't do anything with it. Now, compounding that problem is that generally we're using more power now than we did in 2011. At the time, for example, we only had 1 fridge. We've got 4 now. And everything you buy has got keep alive circuits in it. Nothing ever physically switches off anymore. Everything's running all the time. In the background there's circuits, keep alive circuits going, so everything switches on instantly. There's no startup sequence, if you like. And things like laptops and screens and stuff, they your laptop can draw 100 watts while it's running, and probably more with the external screen on it. So if you just walk away and leave those running, which we tend to do, there's considerable consumption in all of that stuff. So as I said, we used to be about sub 20 kilowatt hours a day. We're now well into the mid-20s. And there's less people here, I think, overall, because kids have moved out, etc. But, we just have more stuff running. So what do you do about it? I can't do anything with the system I've got on the house. That's staying until 2028. And at that point, when I lose that feed-in tariff, and I assume when that goes in 2028, there'll be no feed-in tariff at all, because that's what all the other states have done, where we've got this feed-in tariff because it's locked in legislation. And if you change anything, you lose it. If the ownership of the house changes, it's gone. It must stay in. You can change it to your spouse's name, but that's it. Pretty much. Anything else changes, you lose it. So I can't do anything with it. I'm stuck with it. So what do? The only thing I can do, because the other thing that happened was hot water's gotten far more expensive. I used to pay, I think in 2008, 12 cents a kilowatt hour. We're paying over 20 cents or something now, a kilowatt hour. So a major part of my bill is hot water, which is not offset by the solar production at all. So, as I say, so compounding problems, degradation in the system, performance, and increasing energy prices, increasing kilowatt hours used, and through life, I guess. The only thing I can do is move stuff off the house system, reduce demand on my house system, and therefore feed more power in. So here's my approach. This is how I did it. My approach was to go partially off grid. So reduce the load. What things can I put on there? The majority of stuff is scattered all over the house, but there's one thing that's a constant draw, 24/7, always there, always running. That's the fridges. So my approach was, I'll get those fridges off the house. I'll move some of them. I don't know how many I can power, but I'm going to get the majority of them off the house supply and power those from my shed. So I decided I was going to upgrade my shed solar system, which I've had for many years, but it was only a small system designed to run 12-volt fridges that I repair during the night and run some lights and stuff in the shed. And it did that okay for many years. I've been, as I say, 5, 6, 7 years. I don't know how long I've had that in there. Time for an upgrade. And if I'm going to upgrade it, let's make it big enough to run these fridges. So let's have a look at that system and what I did. All right, so here's a system diagram. I drew this up. I like to have a diagram of these things. I've done it for any of these things I build in the caravan, etc. Let's just have a bit of a look at it. So what I did was, first off, I went out and bought 4 new solar panels. And these are, as I say here, Jinko 440 watt solar panels. Now I managed to pick these up brand new, $50 each. I think one's a $390, so one's a $430 and 2 of them are $440s. But anyway, $50 each. Now what happens is the installers go out to install a system and they end up with 1 panel left over because it won't fit on the roof or something. That sort of situation, or maybe 2 panels left over, depending on what the system looks like. So you can pick these up pretty cheap, but even brand new, you can pick up a 450 watt panel similar to this of good quality for about $90 at the moment. There was a guy advertising on Facebook Marketplace. He's got them for $89, 440 watt panels, and he's got pellets of them. So there's no shortage of these things around, and these are brand new, not second hand. So, and most of these panels are rated at 440 plus several percent, 3 to 5%. So they'll put out more than 440. So I bought 4 of those, all from different. I've got 1 from one bloke, 2 from somebody else, another one from another guy. So I picked all those up and pulled down the old panels I had on the roof and replaced them with these. And here they are there. So I've mounted all those strategically on the shed, on my shed roof, with at 27 degrees, which is optimum for Brisbane. So, and as you can see, they're in full sun, and they're doing a great job. All right, so let's have a bit more of a look at it. So that's the panels. I then had a solar controller that I was using previously, was a 30 amp. Now, given this has got a production of around 1200 watts, this was my old controller, was not going to cut the mustard here. So I managed to pick up one of these Lumiax controllers off somebody. It was a brand new one. Now these are rated at 80 amps, as you can see. And it's got Bluetooth in it, so you can have a look to see what it's doing, but it's also got a inbuilt screen, and that steps through all the time, showing you how many amps, what the volts are for the PV, how many amps are going into the battery, etc, etc. So I picked this up for I think $60 or $80. Now they're usually double that, so that was a fairly good buy. So now I've got the capability to push out, as I say, 80 amps, and yep, so there we go. So I bought that. So I've got $200 here, and I've got about, I don't know, I think that was, might have been $80, $1 an amp. Okay, anyway, it was a good buy. I had a look what else. There's not a lot around that'll do. That's 60 amps, not 80 amps. There's a technical error there. Ignore that. MC60 stands for 60 amps. That's about as big as you can get in a 12 volt. That's going to work effectively. You know, after that, you're starting, these wires become train line. I mean, you know, they're just got to be huge diameter. Right, I'm going to fix that error. So that required, I added this, the other system was fairly basic and didn't generate much, but I did have a breaker on it, but I had to buy a new breaker. So 100 amp breaker, breaks both sides of the circuit, and that feeds into, this is feeding into the solar controller. The output of the solar controller goes to the BMS, via the BMS into the battery. So down here we've got an isolation switch. Now I've provided a common negative here, if you like, or a common earth, coming out of the solar controller and from the battery. This is a, you know, low, you know, maximum probably, or maybe I'm going to have this cable here is, I should have drawn that bigger. It's a much bigger cable than that. It's not indicative of what it's doing, but anyway, I do have a lot of stuff running in the shed off 12 volts, so I've got a 12 volt supply coming from this. And one of the reasons this system is 12 volts, in case anybody's going to comment on this, is because all the stuff I'm running in the shed is 12 volts. So rather than have conversion down from 48 or 24, I just decide to run to that. So that feeds out. So I've got a disconnect switch here that I can isolate the battery. I've got a nice big fuse on that. That's actually wrong. I've got a breaker on that, 80 amp breaker. And here I've got a fuse coming down from the battery that runs directly to an inverter. So let's have a look at this battery. This battery, I managed to pick up this 300 amp hour battery, brand new. And that came from a battery recycler, and he had this, somebody had brought this battery in, and they tore it apart to have a look and see what the cell quality was, what the build quality was, because they were going to retail it. And this comes in a battery case, and so they sort of pulled the whole thing apart. But that was, and now it's unsaleable, so they weren't interested in hanging on to it. They weren't going to do anything with it, so they just disposed of it through a battery recycler. But it's brand new. So I picked that up for 220 bucks. So out here I've got the feed in coming in through the battery isolator. Now that's to feed everything else and isolate the battery from the other electronics here. But I've got a big fuse. I'm trying to limit what I do here with the inverter. So that's got a big 200 amp fuse, and I've got to fit something to that. I've got to I'll probably have to put another one of those big breakers on it, I think. But I've got it protected currently. So this is sort of organically grown, this system, over the last couple of weeks. So so forgive me if I haven't got everything in here. I've got a JK BMS, as you can see. That's a 250 amp BMS. And again, that's got Bluetooth on it, so you can see exactly what you're doing. You can set all the parameters, etc. Now, there's plenty of stuff on that on the internet. I don't have to, You can have a look at Andy's off-grid garage if you want to see all about. He knows these things, and I got all my settings from him. He knows these things back, front, and sideways. So now the next thing was I had a 1,000 watt inverter, which I'd previously had installed in the caravan, and I thought, well, that was a Renogy. Renogy stuff I've found is pretty good, but problem with the Renogy, as someone else commented, I saw someone else's had changed from this. The Renogy just randomly does alarms. Something causes it to trip out, and keeping in mind that a fridge draws about 150 watts. So my little freezer I've got for dog food it is a 140 watt freezer. Now it's an old piston compressor. That Renogy thing, if you just plugged it in, or if you cut it over from running on the grid to running on that, it would trip the Renogy inverter out, and it would not. It just wouldn't run. So, and it would take several attempts to get that to work. So, but you've got no idea. It doesn't tell you if it's over voltage, under voltage, over current. I've got no idea what the alarms that are generated now. As I said, I run Renogy stuff in my van. It's good. I've got a 2 kilowatt inverter. But I thought, no, I'll just go and get something else. So I had a look on Amazon and I bought this thing. The other thing, Renogy, you've got no way of looking at what it's doing. There's no Bluetooth. There's no external panel for it. There's an external switch on off, that's it. So very basic in its operation and quite functional. But given that the Renogy is about $300, just 320 or something like that, this thing was the same. And I saw a guy do a review on this thing in the States, not called this brand, but it's the exact same inverter as far as I could see. This has got a remote control on it, which is good. And it's got a display telling you, over voltage, under voltage, over current, etc., overheated. So those functions are on this thing, and it's more compact. It's a shorter, smaller inverter, and it works fine. I just going to 2,000 watts to be able to sustain 2 fridges trying to start at exactly the same time. That would not work with the Renogy. This one has no problems with it. Well, it might have been all right with the 2 kilowatt, but I also wanted to be able to see this thing working. So that's the Ubi Nova. What a ridiculous name, honestly. 2 kilowatt pure sine wave inverter, and it works well. I've run my shock vac on it, and that struggles to work even off the 2 kilowatt Renogy. But no problem starting that. It works well. So it can handle 4,000 watt peak surge current. So it does a great little job. $319 from Energy delivered from Amazon. Delivered. Output of this. Okay, so that's got all. Now I'm able to generate 240 volts at this point from solar. So I've got all this running, and then came the problem if I'm going to run my fridges as well as my shed. I'm only showing the fridges on this diagram too, by the way. I'm not showing the shed. What happens if this doesn't get enough sun? If we get several days overcast and the battery runs out? Because this battery will run my fridges for about 2 days, with limited, even on an overcast day. I can get through 2 days if I've had a full sun day, and then or partially cloudy, I can go a couple of days, no problems. But if this thing gets down to the point where the JKBMS says, no, sorry, that's too low, this thing shuts down the inverter. And if you shut down the inverter, the fridges go off. Okay, problem. And that happened in my first few days of running this. We had some very rainy days. So I bought this. This is a auto transfer switch. So I had a look to see what was around on that. And there's a number of them, and they look very similar. Regardless of what you pay, they all look very similar. I found this Innertech, I think it's called, on Amazon for $19. So what does this do? Its primary input is solar, and it actually has it on that diagram there. It's a bit hard to see, but it shows a little house with the sun there. So that's the primary input coming in there from the inverter, because I want it primarily to run from that. The grid comes in as a backup power, and it's fed into the other side here.
There's a little switch on the end there. That's an auto manual switch, as is this knob. So you switch it to manual and then you can select one or the other and it won't auto transfer. But in its normal mode, if this stops, this switches to grid, and it does it in less than 50 milliseconds. So your fridges don't even see it. They keep running. So the output from the auto transfer switch feeds off to my shed and these fridges. So I've got 3 fridges running on it, and I haven't done my primary fridge in the house because it's just a bit difficult to get to at the moment. And I probably don't want to run any more on this system currently. So the production from this system is now, on a full sunny day, this controller shows me that I've generated 4.5 kilowatt hours. Now, given that my rooftop system, grid connected rooftop system, generates somewhere around 20 at this time of the year, that's pretty impressive. Now, given that I've got those panels on the roof, they're not necessarily they're across 2 sections on the roof, my grid connect system. So half the panels face north, the other ones face west. So it's a long time before they get into full sun in the morning, and they're not tilted at an angle, because if you tilt them, you have to spread them further apart, and eventually you're going to run out of roof. I certainly couldn't set them up at 27 degrees as I've done on the shed. I don't think. Anyway, I haven't done that. That's something I could do to improve performance again, and I might look at that later, but I thought I'll do this first. So this serves a dual purpose too. The second bonus in having this system is I have now got my fridges backed up for what's becoming a much more regular situation. Is in this time of the year we get, or not this time of the year, but in summer we get big storms come through here. But even in the last 2 weeks, we had a big storm came through, and I think there were 20,000 properties with no power for 24 hours, or it took them a day or so to get it back on. I've now got my fridges supported with backup power, and I can run even the primary fridge in the house. I can run an extension cord from this system up to run that, and that will get me through 24 hours, no problems. So this is a real bonus because, if the power goes off, the one thing you want going is your fridge. All right, so let's have a bit of a look at the actual hardware here in the shed now. Don't look at me critically here. This is in its infancy. I've redesigned this thing about 3 times. So once I've finalised what I want this to look like, I'll, rebuild the thing properly on a board. I'm still in its organically growing state, so bear with me. All right. I love this meter. I found this somewhere. I got this off somebody, that's right, about 30 years ago, and it came out of I don't know, an old Telstra site or something. I don't know what it came out of, but this comes from Master Instruments in Sydney, who are a big manufacturer of meters in Australia. It's a bloody ripper. I've had it here in a box for years, thinking one day I'll find a use for a 60 amp meter. So I installed this with my old solar controller, because at a glance I can just see. It's interesting to watch this when you're getting a bit of shade coming across, and you can see this needle wandering back and forward. So at a glance, this is quite accurate. So 60 amp meter with a matching shunt. I've got that mounted here. I could put it on the back, but anyway, just as I said, organically growing. Let's get the stuff. So here's my breaker coming in. I showed you the panels before, 80 amp dual breaker there. The output of that comes down, feeds into this Lumiax 60 amp MPPT controller, which is auto selects. These are a great controller, they work really well. So it will auto select its voltage. It has a meter on it. As I said, there's PV battery 14.4, 60 amps. It's right on the button. According to this, it's actually producing more than that. And it's got a load output, which it may or may not use. A lot of these controllers have these load output for running street lights or something. I don't know what. Anyway,
not something I use, but it's rated to 30 amps, I think, the load output terminals. So you can run quite a bit of stuff off it. So PV's at 31 volts, 28.4 amps coming off that. Battery's at 14.2, 59.9 amps according to this. It's actually higher than that. There's the battery isolator switch, big 150 amp battery isolator switch here. That's running down to the battery. The output from the so the solar comes in to here. The output to the battery are on these terminals. So I've got a common ground, I've called it, but common earth if you like. And again, that's coming up from the battery. This one's coming up from the battery. So up here I've got the JK-BMS remote control panel, if you like, or the display panel. Tells me what that's doing. Now this started off this morning at 20%. And as you can see, we've got 57.6 amps going into the battery here at the moment, 58. Now that is because up here, this is the Ubener control panel, and that this actually works wirelessly. I've got this wired in, so it's permanently on, but you can run this thing wirelessly up to 30 meters away. And it shows you the input terminals, the output voltage and frequency, and the load that it's currently on there. So I've got 96 watts drawing from that, which is why this says 58 and this says about 64. If this was turned off, I'll turn the fridges off, hang on. If I hold this in, now that was the auto transfer switch switching over to grid. But now it's just, so here this is showing you what this is actually putting out. The solar controller here thinks it's at 60 amps, as it will tell you on here. There, reckons it's right on. It's actually generously putting out 66 amps. Now one of the things I had to do with this is this actually gets quite warm. First off, I spaced it off the wall a bit to improve airflow up here, but that didn't sort of suffice. So I've put a little 60mm fan in behind it, and that's operated thermally. There's a thermal switch here that cuts in at 35 degrees. Because what I noticed was this was dropping back to about 55 amps once this was in full sun, and it was really belting out, put 900 odd watts was coming in from off solar going through this thing. This thing got hot, so yeah, so I thought, well, I'll put a thermal switch so that cuts in automatically, and that gets this back up to pushing out maximum, as I say, 66 amps. And it does that all day, no problems at all. This controller works really well. This Lumiax, good. I bought a contacted Lumiax and said I wanted a method of increasing the range of the Bluetooth so I could see it inside the house. And they shipped me out a little remote Bluetooth, which runs off a there's a RJ11 socket on the bottom here, 6-pin. That runs, I bought a 6-meter cable for that, and that's it hanging up there, and I can see that in the house, no problems at all. So that works well. I could extend that further. It doesn't cover the whole house, but I can at a glance look at my phone and see what the production's doing. Only because I'm being a nerd, I could come out here and do it, but I just want to be able to see what it's doing. It'd be nice to be able to see that if this thing and this thing would connect to Wi-Fi, to the Wi-Fi network, that'd be great, but it doesn't. So anyway, that's what this thing's pumping out, 65, 66 amps. It because I'm keeping this cool, that fan goes off, this will drop back to, it'll probably be back to 10 amps, it'll back off. So but it does that all day, no problems at all. So then I've got down here, I've got as I said, some cigarette lighter plugs, an Anderson plug. I haven't got all those on the diagram, but they come off this feed here. So I've got a fuse here. This purpose of this fuse here is for the feed in. So the feed in comes from here up through the fuse, through the shunt, and then goes through the isolator, battery isolator, into the battery. So all in and outgoing goes through this fuse, apart from, this is all for my general load in the shed at 12 volts, but not to the inverter. I've got my inverter, it's down here, mounted up, upside down underneath a shelf. It's got fans that come on if it gets too hot. And just below that, this is this battery I bought with the JK BMS. I'm trying to figure out what I'll do with this, is if I bother repacking it or put it in something else. I don't know. Not decided yet. As I say, it's still in its interim phase, trying to figure out if this is everything I need. But this is the JK BMS. And then from the JK BMS, I've got positives go directly to the battery, the negative goes through the JK BMS and out, and I've got one terminal feeding the inverter. The positive of this goes through a fuse up here, as you can probably see. I've got a big fuse on it. As I say, I'll probably put a battery isolator on that thing, I think, so I can shut that thing off. But it does have protection, that's the main thing at the moment. I've got a spare outlet here if I need it. But I don't tend to use this for anything other than really run on the fridges. But if I want to run an extension cord to something else during a power outage, I've got a second outlet there. But I've also got another outlet back in near the fridge in the house. So that's the system. Now, so temporarily, what I did was I had to run power to the house. So I wanted some 15 amp cable. I picked a heavy duty 15 amp cable up from Facebook Marketplace, which was a 20 metre caravan, heavy duty caravan extension cable, and I've currently run that out. As I say, all in development, and it runs out underneath the house there and then continues on to feed the fridges. And that's, as I say, the draw is very little. So I'll put this back on. Now down here, auto transfer switch. I've just ordered a housing for this because I had to see it to find out how big a housing I needed to house that in. And currently it's only showing availability of grid because I turned off the inverter. I've only got grid available and it's running on grid. You heard that big clunk, that was it shutting over. And if I put this on now, if I bring this back on, this thing will switch. As soon as that 240 comes up, there you go, bang. And at the moment there's one fridge running. As you can see, it's drawing 71 watts, no, 100 watts. That's one of the fridges, I don't know which one, but quite often that can be up to 200 or 200, 300 watts if all three of them are running. So now you'll see my production here's dropped down to 58.2. I'm still generating over 60, around 65, 66 amps. But 7 or so amps are going to this, about 7 amps at 12 volts is 100 watts, so that's about right. So that's the system. This meter here is a 12 volt. I've got that looking at my 12 volt socket so I can see the current draw going off to the 12 volt items I've got connected to it. So as I say, this is very much in its infancy. I've changed this several times and I don't know that I'm finished yet. As I said, I've got to fit something to that, so I'll probably put a piece of timber across here, make this thing a full size sheet, and then recut the hole for this and remount everything, and get something. These don't have these are weird, these things. They don't have a housing or anything. It's just a straight there's nothing to hold that in. I've just made up a couple of bits of wood. I'm going to get someone to make me print me a 3D housing for it to sit in. Equally, I made this out of a PowerPoint bracket I had, and I mean it's adequate, but it'd be nice to sort that out better. I could mount them into the wooden panel, which I might do, but I'm trying to figure out how I'll put all these, to make a bit more sense of it. I mean, that and that and that should probably all collectively be somewhat together. Anyway, I'm going to think about that for a little bit before I go any further. Point is, at the moment, this all works really well. The cabling size seems to work. Nothing's getting too hot. This is warm. That's 25 mil. But no, the other cables aren't. That's not even warm, that big one there. But so I could probably upgrade this, but there's a certain size you can get to here where it won't fit in the hole. And I'm going to move this, so I'm not doing anything with it at the moment because I will relocate stuff, I think. Got to have a better plan. Anyway, so that's what that system looks like. You saw the panels, I showed you those. And she's pumping away. So there we are. It's now 10 past 10. This really hit its bootstraps at about 2 hours ago. This was up at 55 amps. And I'm already gone from 20% to 56%. So on a sunny day, during the day, I could easily run the washing machine, whatever. I could run more stuff on this during the day, which would be good. I could shed the load. If I got a full sunny day, I could be running the fridge in the house as well during the day when I'm paying, which is when I'm getting my maximum 44-cent feed-in tariff. I want less load from the house on stuff. The less I've got running, the more I produce and the lower my bill gets. Because with the feed-in tariff, the big issue is it's offset by your solar on your general use tariff, but in fact half of my bill is hot water. Now I can't run hot water off this; it's not big enough to do that. So I can only shed load really off the general tariff, but the hot water is expensive, so I don't think I'm going to do anything about that. I just want a zero bill, really. If I get to a zero bill or a slight credit, that's great. I probably don't even need this in summer, really, but it's good to have this backup. This is another major reason to have this is of my house fridges are now supported with a battery. So I've sort of gone off grid. I'm partially off grid. All right, well that pretty much covers it all off. Sorry that's been a bit long-winded, but wanted to go through how that works, at the hardware, the diagram, etc. But I think the takeaways from this are that I've now got, I've shed a considerable load off my system, probably around 3 kilowatts a day of power, is now running off-grid from the shed. And that's a bonus. I think I've turned around my electricity bill by around probably $80 to $90 a month. I reckon that's the difference from what I've seen so far. It's considerable. But even if it's less than that, I figure my return on investment's probably under 12 months. And from then on, I'm further ahead. But also just as important, and one of the things I always wanted to achieve was to provide support for the fridges in case of power outages, because we do get these storms every year and they are getting worse and they're more extensive. We've had storms right through this year. This is very unseasonable. Last Friday night we had hailstones and a wet season storm typical of January or something, when you're in the thick of it. And as I said, a lot of houses lost power. So I've now got support for those fridges during power outages, and that's just critically important that your fridges work, because you walk away from a lot of food. And I've got power. I can run some extension lead up and run a light or two in the house as well. It'll support all of that. I can run a generator to recharge that battery during the day. That's something I've got to yet provide a connection point to. But essentially, I've got a charger there, which I haven't made part of this yet, to support that. So that's a real bonus, being able to support all your fridges through storms and being able to have electricity when everything's gone off. So having that capacity is twofold, and just as important is that storm support, because things aren't getting better, they're getting worse, and we're getting more frequent outages. All right. Well, thanks. If you're still here, thank you so much for watching. Please subscribe if you want to sit through long-winded descriptions of these things that I do. But anyway, I haven't done one of these for a long time, so hopefully this has been of some interest to people who are in a situation similar to mine. And roll on 2028 when then it'll be time to make a decision about batteries and new systems, etc. When it's probably cheaper, probably things are settled down. It's out of control at the moment, and people are paying a fortune, I'm sure, for upgrading their systems and adding batteries. That'll have settled down by the time we get to that. So this sees me through till then, and then I'll decide what I'm going to do. All right, thanks a lot for watching once again. Give me a like if you do like it. Thanks.